while prompting our agent, there are three major steps involved. First is to gather context, which is to find the relevant files, and also it might also make web requests to an external API. You paste your error into your coding assistant, and within a few seconds your coding assistant tells you which files to look at, fixes your bug, and also runs the tests to confirm it works. But what most of the people don't stop to think about is that coding assistant, the LLMs, itself cannot read AI, itself cannot read your files. It cannot access your permissions, it cannot access your terminal. And I'm talking about LLM, not coding agents. In this video, we are going to break down this mechanism underlying every coding assistant, which is called tool use. The first thing to note is that LLMs process text as input and they produce text as output. There is no access to file system. There is no access to any other external actionable API, because that's what LLMs are. It's just a very sophisticated text transformer. And while prompting our agent, there are three major steps involved. First is to gather context, which is to find the relevant files, and also it might also make web requests to an external API. Second is to formulate a plan, to form a plan on how to approach the fix. And the third is the action, to actually edit the files and perform actions. So first and third step are what require our LLM to interact with the real world, and we know that our raw LLM is just incapable of it. Let's say you are the user using this codex agent, and this uses some AI model. Let's say you tell the codex to fix some problem in your code base. Now codex is not going to send a raw request to the LLM. It is going to send the request along with some instructions, and these instructions contain the list and details of tools available for use. Now LLM is going to read your request and determine, let's say for example, that it needs to read a file called rust.rs. It is going to send back a response to our coding agent that, hey, read me this file, and we already have this particular format defined within the coding agent. Our codex is going to read the file contents and feed this content back into the LLM. LLM is going to process this content and return the result. However, this is not a single step process, and there might be many back and forth calls involved. And also you can chain tools together. So that was about how tool calls actually work. However, all coding agents are same in context of how tools actually work. However, what separates great coding agents from good ones are the following. Number one is the tool choice. Given a vague goal, your LLM should be able to determine which tool to use out of the list of tools available. A weaker model might just use the wrong tool, or it might use a tool again when it already has the result. Second is tool chaining. Tool call is not just about using a tool, it is also about reading the user's permission, fetching the records, and also updating the records. A good LLM is able to track the current state of the tool call in the tool chain and also the next step in the tool chain. Third is error handling. Tools fail and we might receive empty data, partial data, or errors. A good LLM is very good at error handling. It should be able to tell when to use a different tool call, it should be able to tell when to retry, when to use a different tool, and when to ask the user for help. A weaker model might just hallucinate past that problem. The fourth step is also important because you must know when to stop, because using tools costs money and time. This is also where Claude's coding agent is superior, because it doesn't just index your code base upfront. It is not going to send your entire code base to a separate server. Instead, it is going to use tool calls to navigate your server intelligently. So better tools not only mean better answers, but it also means better security. So here's what to take away from this video. AI agent is not just about reading and writing code. It's an AI embedded in a system that gives its hands, so to say. The better the model is at reasoning, the better your answers will be, and also you can extend it more. So let's say you introduce a new workflow to your model. Your model is going to adapt to it. Let's say you introduce your agent to a tool that it has never seen before. It's going to adapt. Let's say you introduce your coding agent to a workflow that is custom to your team. It is going to adapt. That's the real promise of using tools. Not just that your coding agent can write and write code. Not just that your coding agent can write code, but it can also grow as your workflow grows.